A new ALMA image has revealed extraordinary fine detail that has never been seen before in the planet-forming disk around a young star. These are the first observations that have used ALMA with its antennas at almost their maximum extent. This has resulted in the sharpest picture ever made at submillimeter wavelengths. The new results are a huge step forward in the observation of how protoplanetary disks develop and how planets form. This is the ESOcast, cutting-edge science and life behind the scenes at ESO, the European Southern Observatory. ALMA, the Atacama Large Millimeter submillimeter array, is the world's most powerful telescope for observing the cold universe. It consists of 66 high-precision antennas that can be placed in different configurations. For the first time, the ALMA array has now been configured with the antennas up to 15 kilometers apart. This is close to the maximum possible baseline of 16 kilometers and allows ALMA to discern much finer detail than has ever been possible up to now. For ALMA's first observations in this powerful new mode, researchers pointed the antennas at HL Tauri, a young star about 450 light-years away, which is surrounded by a dusty disk. The resulting image exceeds all expectations and is sharper than images routinely obtained by the NASA ESA Hubble Space Telescope. It reveals unexpected fine detail in the HL Tauri protoplanetary disk, which consists of material left over from the birth of the star. The image shows a series of concentric bright rings with enigmatic dark patches. These structures are clear signs of the presence of multiple planets as they sweep up material from the disk. HL Tauri's disk appears to be a lot more developed than would be expected from the age of the system. This suggests that the process of planet formation may be faster than previously thought. Young stars like HL Tauri are born in clouds of gas and fine dust, in regions which have collapsed under the effects of gravity. Dense hot cores form and eventually ignite to become young stars. These baby stars are initially cocooned in the remaining gas and dust, which eventually settles into a protoplanetary disk. Through many collisions, the dust particles will stick together, growing into clumps the size of sand grains and pebbles. And ultimately, asteroids, comets, and even planets can form in the disk. The young planets will then disrupt the disk and create rings, gaps, and holes, such as those structures now observed by ALMA. The investigation of these protoplanetary disks is essential to our understanding of how Earth formed in the solar system. Observing the first stages of planet formation around HL Tauri may show us how our own planetary system may have looked during its formation more than 4 billion years ago. By operating in its close to final configuration, ALMA has demonstrated its enormous observational potential. This starts a new era in our exploration of how stars and planets form.